Everyone, and thank you for attending today's sessions. So welcome to the to When Podman Desktop Eats CLI Dwellers Eat Too session with Urvashi and Ashley. Take it away.
Thanks, Preeti. Hello, everyone. My name is Urvashi Mohnani, and I'm a principal software engineer on the containers team working in the Podman and Friends area. Ashley?
Hi, I'm Ashley. I am a software engineer also on the container runtimes team, also working on Podman. So our talk is When Podman Desktop Eats, CLI Dwellers Eat Too. And basically the gist or the thought behind this talk is that by now you've seen Florent and Stefan present their Podman Desktop demo and all the shiny new features that have gone into Podman Desktop, and it's a wonderful GUI. But we also know that there's a lot of people who don't necessarily love using a GUI, but the benefit of having the Podman Desktop GUI is that a lot of requirements came in from that team, and so we've made a lot of improvements in order to support the development of Podman Desktop. Which means that these features are in Podman itself, so you don't have to use the GUI to be able to if you prefer not to use a GUI, you still get these cool features and improvements that we've done over the past year or so. So the first thing I want to talk about is Podman Machine. Podman Machine has been around for maybe like a year or two, but I think at the last Container Plumbing Days, which was not last year, but 2 years ago, I think, Podman Machine was pretty much like either in its infancy or not very fully developed. If you're here from the last one, I just want to talk a little bit about Podman Machine. So as we all know, Podman is a Linux-only or containers is a Linux construct. So if you want to run a container on Mac and Windows, you have to use a VM. What we came up with was Podman Machine, which is kind of a VM manager that configures VM for Podman on non-Linux systems. And we wanted to do this in a way that made it feel as native as possible. So after doing a Podman Machine init and a Podman Machine start, you would run Podman commands as if you were on a Linux box without having to fiddle with other custom configurations. This includes this also means that we mount your home dir into your VM, and we expose ports onto the host machine, so you don't have to worry about networking in and out of the VM. It just works. So like our big idea was it should just work out of the box. But at the same time, Podman Machine gives you the ability to customize your machine if you would like to. I know some people have certain requirements with how they need to set up their container development environment, and if those people wish to customize their VM image and stuff like that, we give them the capacity to do so throughout a lot of the options we have on the CLI. So again, it's as simple as Podman Machine init and then Podman Machine start, and then you can run Podman commands just as you would on a Linux box. A new command that we added really recently is Podman Machine OS, and it takes advantage of Podman machines that use Fedora Core OS at a space. So by default on Macs and Linux for Podman Machine, Fedora Core OS is the operating system within within the VM, and this takes advantage of RPM OS tree's ability to rebase itself through the wonderful work that I think there's a talk tomorrow on it on Fedora Core OS and bootc and stuff like that, and it takes advantage of a lot of the work that's been done there. And this is really cool because you can use standard container images, in order to update stuff that goes on inside of the VM. So you can use Podman to build the image. You can use Podman to build the image to update your VM, and this allows versatility with system upgrades and testing, especially if you want to use, a version of upstream Podman. You can rebase the image you can add the newest upstream Podman into your VM image and use that. This request kind of came in, or this was particularly helpful when we were dealing with Podman Desktop, because a lot of the times the desktop team wanted the newest version of Podman to test inside of test with desktop. And with this feature, they're able to pull in the very, very newest Podman and make sure that that Podman is in Podman Machine so that they can use it to test. This also means that any user can use this new feature to customize their OS and or Podman Machine OS, and maybe get the latest version of Podman within it, and not have to, if they want to test the most upstream version of it. So that command right now is Podman Machine OS apply, and you give it a standard image. And then in the future, what I'm currently working on is Podman Machine OS revert, where you can go back if you don't like the changes you've made into the system. So I have a little bit of a demo with this. So what's happening is that I'm going to create a Podman machine using Podman Machine init. And parts of this are sped up just because I don't want you sitting here watching, things happen. But we're going to start up the machine. So this is a brand new machine. And then we can see it's started. So we do a Podman version, and we can see inside the machine, the engine is version 4.4.1. The client is 4.5. So we're going to take a look, and this is just a regular container file, nothing special other than the base image is Fedora CoreOS, and we're going to use Podman build. So if you notice, there's nothing special about using a machine. If you use Podman commands like Podman build, it just feels like it's native. So the only new thing is the Podman machine init and Podman machine start. Podman build, Podman run, everything else feels the same. So right here, we're building the container image with a new Podman version in it. If I don't know if you caught it in the container file, but we're replacing the old Podman version with the latest upstream version. And we can see in our images, we now have Podman Next, which is the image that we just built. And I'm going to take another look at the version, still 4.4.1 inside of the VM. And then if we do a Podman Machine OS apply to Podman Next, RPM OS tree will rebase, Podman Machine will update itself using RPM OS tree in order to pull in the packages that we built from the container image. This requires a Podman Machine stop and a Podman Machine start, a little reboot for it to take effect. So it started again, and then if we do a Podman version, we can see the Podman inside of the machine. The Podman engine is 4.5. So that's just one of the examples that you can use for this. Of course, you can use it to update your OS in a bunch of different ways. And it also allows people who want a unique environment within their Podman Machine OS to be able to do that as well, without having to deal with, like fancy like VM image builders. You can use a container builder and rebase itself on top of that. So these are so all of these machine ideas are so that Podman Desktop is also able to have a smoother transition, because a lot of the Podman Desktop user base is not on Linux. A lot of the Podman Desktop user base is on Mac and Windows. And so Podman Machine is kind of crucial for the user experience on Mac and Windows. So we've been doing a lot of work on that. And again, as Dan said, thanks to Colin Walters, this is a really, really cool feature that we were able to sorry about the sirens in the background, that we're able to take advantage of. And and do more work in this area. So another cool thing that happened while working with the Podman Desktop team is a lot of people in those Windows and Mac environments might work in a corporate lockdown system. So a lot of times, traditionally, the Mac OS version of Podman, you had to use Homebrew to get. And a lot of customers on the desktop side realized that getting it from Homebrew is not part of their, enterprise security policy or whatever. So now we ship a macOS package installer, a Windows.exe installer, and a Windows.msi installer. These are air-gapped installations, so you don't need to pull from upstream repositories in order to be able to use Podman or Podman Machine, and these are all inclusive. Everything's in it. You can find these binaries on our GitHub release pages. So right now on the Windows side, we do use WSL, and we're slowly transitioning into HyperV, because again, a lot of the environments, we've gotten feedback from the desktop team that a lot of people aren't able to use WSL on their corporate laptop and stuff like that. And so we're slowly looking into HyperV at the current moment. Hopefully it will be out soon, but we're definitely we're adding support, and then eventually, so we're adding support for HyperV as well as WSL. So that's something to look forward to. And then some other features that we've been looking at is that we've boosted our API compatibility with the compat flavor of our API. So a lot of times, people who want to be able to use their old Docker scripts with the REST API, we've made sure that we fixed a bunch of bugs in the compat layer that were found while developing Podman Desktop. We also have a better VS Code extension support. So traditionally, a lot of developers who do use a desktop experience like to use the desktop with VS Code. So and then on our side, we made sure that the bits and pieces that make Podman work with VS Code are working very nicely. So VS Code, the Podman VS Code extension should work very well. A little bit unrelated, but kind of related, Pasta networking. We enabled, there's a new feature that allows Pasta user mode networking, and then also multi-arch builds where there's an effort to make multi-arch builds smoother. Again, this also comes from the fact that a lot of users of desktop, and also maybe of Podman as well, are on Macs, and because of this personality split of N1 Macs versus Intel Macs, a lot of people want to be able to build Intel images on an N1 Mac because most of the world still works on Intel, but shiny new Mac that's very fast. You want to be able to take advantage of that. So we're looking at multi-arch builds on with ARM and also x86. Oh, you're muted, Urvashi.
Sorry, I was on the other tab. All right, so in addition to all those other features, we've made a bunch of performance improvements with regards to memory and speed within Podman itself. So Podman is lighter and faster now for your edge devices, but due to the harder restrictions from Edge. But even though it was kind of driven by Edge, it's also very beneficial to Podman and Podman Desktop in general, just having a much faster tool. We also have integrated Quadlet into Podman as of version 4.4, I believe. Quadlet just allows users to use Kubernetes YAML files to deploy the containers with systemd and Podman. So this is also just driving all of the Podman Desktop improvements. So one of the goals of Podman Desktop is to introduce container users to the Kubernetes world. And kind of similar goal as for Podman CLI as well. So with regards to that, we have three commands in the command line tool, as well as on Podman Desktop: Kube generate, Kube play, and Kube apply. What these do is auto-generate Kube YAML files for you, or play the Kube YAML files for you with Podman, or directly deploy it into a Kubernetes-based cluster. So to dig deeper into each of these commands, Podman Kube generate, as the name says, it generates a Kubernetes YAML file for you. You just have to pass in the container ID, the pod ID, the volume name, secret name, etc., and it will create a Kube YAML with the Kubernetes kinds with respect to that. So we currently support pods, services, PVCs, and secrets in the Kubernetes objects, and we are actively working on supporting more Kubernetes objects right now. One that is in development is supporting the generation of deployments. Kube play is, you can say, the exact opposite of Kube generate. So you can just take a Kube YAML file, pass that into Podman Kube play, and Podman will go through the definitions of the containers, volumes, secrets, etc., and create those resources within Podman itself. Use case of this is, let's say you have a container pod running in a Kubernetes environment and you want to debug it locally. So instead of trying to, transform the Kubernetes YAML file into like a command line that Podman can understand, you can just plug in the Kube YAML file within Podman, and it will create all the containers, pods, and other resources that were defined in the Kube YAML file. One improvement that we added to the Kube play command is the wait flag. What this does is, when it's enabled, the Kube play process kind of stays in an attached state. So that when a user goes and kills it, or the containers and pods have run to completion, all the resources that were created during the Kube play process will be cleaned up. So you don't have any remnants left over. For the case where you ran the Kube play process and completely forgot about it, it'll automatically clean up after you. This is kind of similar to what Docker Compose does as well, and that's kind of where the feature request came in from. And the next one is Kube apply. So we wanted to cut down, the middle command of generating the Kube YAML, picking it, and then transitioning it to a Kubernetes cluster to deploy it over there. We kind of wanted to be able to do this directly from Podman itself. So using the Kube generation code we already had, plus the Kubernetes API endpoints, we can connect to a Kubernetes cluster as long as you can pass in the kubeconfig file to it, and it will directly deploy any containers or pods you have running in Podman to the cluster when you pass in that container's ID or pod's ID to it. The kubeconfig file here is important because the kubeconfig file holds, authentication certs and all that you need to be able to connect to a Kubernetes-based cluster. And any Kubernetes-based cluster will have a kubeconfig file associated with it. This kind of also highlights our, single node to multi-node kind of transition from moving your workloads from a developer use case to a production use case. So I have a quick demo on these commands that I just talked about. Okay, that's sharing. What I'm going to do here first is I'm going to create a simple container with Podman. I'm just creating an Alpine container with the sleep command. And then I'm going to use the kube generate command, pass in my container ID, and then write it to a file called mygenerated.yaml. The dash F flag just reroutes the output to that file. And then we can take a look at the file here, and you can see a simple pod definition was created in the kube YAML there with my container name and the container command and the image. So now I've removed the container I created that I generated the kube YAML from. As you can see, I have no containers running right now or created right now. And then I'm going to use the kube play command and pass in my generated YAML that I had generated from my previous container. So as you can see here, it created a pod and a container because in the Kubernetes workload, all containers run within a pod. So we followed that with the kube play. And as you saw that when we did the generation, it created a pod definition because there's no singular container definition in the kube YAML format. So it created a pod for me, and then I have that Alpine container and my infra container running within the pod. So that's kube generate and kube play, the back and forth of transitioning from Podman to Kubernetes and back. So the next thing I have is I actually have a Minikube cluster running locally. As you can see with my get nodes, my Minikube cluster is up and ready. And I don't have any pods right now in the default namespace. But what I'm going to do now is I'm going to use the Podman kube apply command, pass in the pod that I just created with my kube play and deploy so that can get deployed into my Minikube cluster. And then I'm going to use the kubeconfig flag here to pass in the path to my kubeconfig file. So if you don't want to keep doing this every time you do the kube apply command, you can just export the kubeconfig environment variable in your environment, and Podman will pick that up. That is kind of also how it's done for Kubernetes clusters. I'm not sure why Podman keeps getting printed. I think when I was recording this, that got messed up, but that's not how the output actually looks like. So as you can see, my pod is deployed into my Minikube cluster. I have my pod up and running, and I can also describe the pod and see that it's all up and running in my cluster. So this was just the workflow of generating from a Podman workload, playing a kube YAML within a Podman workload, and then moving your containers from Podman to Kubernetes cluster with just one command. And then back to the slides, I kind of want to show that the exact same thing is available in the Podman Desktop GUI. In the GUI here, I have a screenshot of it. So I have a container running here. And as you can see in the actions, I can either generate a kube YAML similar to kube generate. I can do deploy to Kubernetes similar to kube apply. And then there is a play kube Kubernetes YAML button here that I can click and pass in a kube YAML file. So the Podman Desktop GUI is using all of the Podman CLI and backend stuff to have the same thing working. That's kind of all we have for you today. These are a bunch of resources, some links to some articles, links to our GitHub pages, and our really awesome container commandos coloring book if you want to know more about our other container tools. But yeah, that's all I think Ashley and I have for you today.
Thanks, Ashley and Urvashi. Any questions? I know Scott and Dan has been answering some questions or discussing some things. But other than that, nothing anyone has? What
version of Podman will support deployments? We're aiming for it to be supported in Podman 4.5.
Any other questions, comments? Does Quadlet support Kubernetes YAML?
Yes, so Quadlet supports Kubernetes YAML. The whole point of it is you pass in a Kubernetes YAML and it will transform it into a systemd service file that systemd and Podman can then use to run your containers. Podman also has a generate systemd command, which you can use to directly generate a systemd service file from your Podman workload. So you just pass in the container ID for that. But since Kubernetes YAML files are kind of the de facto standard for defining your containers in the container world, that's where kind of Quadlet came in and is making that transition also simpler.
Should I use Docker Compose or Kubernetes YAML to define complex applications?
I would say Kubernetes YAML, just because, as I said, it's kind of de facto standard. And also the Kubernetes YAML, you can plug it into Podman. You can use it with Quadlet for it, convert it to systemd. You can use it in a Kubernetes cluster, while Docker Compose is only, the Docker Compose format is only restricted to Docker Compose.
Any other questions, Dan?